Up to this point in this series of presentations, we have assumed that we have a notion of word or lexical item available as an unproblematic notion or object. And indeed, I think when we begin with working with computational generative grammar, it's very useful to start from this type of unproblematic, but at the same time, admittedly too simple model. After all, it's almost trivial to create a list of primitive constituents and pretend that they represent words and then build sentences derive sentences from those items. But again, as soon as we move towards more realistic problems, linguistic projects, this simple notion simplification will turn out to be insufficient and too simple. And so you will sooner or later have to face the question of how to build the lexicon, the vocabulary, the list of words, and how to generate the phonological words as they appear in the surface sentences. And this will be the topic of this presentation. I'm going to discuss these issues first again informally, and then I move to address the implementation. But in this case, we can't really go far enough for me to show any source code, although I have, of course, created lexicons for all of my own projects and even for the entry point scripts. But it's simply doesn't serve any useful purpose here. But I will be discussing the general outline of how I think the implementation should be approached. But let's begin with taking notice of several facts that have to do with words, which first show why this simple starting point is indeed completely insufficient. And these are also properties of words that our model will have to take into account. So the first thing we notice is that phonological words, sometimes they appear to be what we could characterize as monomorphemic, so that they are created from some type of single item. For example, the English definite article, the. It doesn't seem to have any more parts. It's just a one atomic element. But that's not always the case. So in English, for example, we can take a verbal stem like run, and then we can create words, other words from it by adding something like running is a noun, and runner is another noun, but the meaning is different, and so on. This is called word formation, and it refers to the fact that language has some type of productive and systematic way of creating not only new phrases by combining phonological words and word boundaries, but also new phonological words, but combining what we can refer to as independent morphemes. So in the word running, the morphemes would be run and ing. And we can take both of these elements or morphemes and then combine them with other words. Sleeping, doing, wanting is ing nominalizer ing combined with other verbal stems. And as I already showed, run can be combined with runner as well as running. So there is some kind of combinatorial system there. And we cannot really describe this mechanism in the end by listing all these separate words in the lexicon. There has to be a creative component that makes such words and understands them. Then another concern is that in all the scripts we have analyzed and looked at so far, the lexicon has been a dictionary, a pairing of the key, the phonological form of the word, and then a set of features. But in many grammatical theories, and for good reasons, empirical reasons, the lexicon could be much more, the lexical items and the lexicon therefore could be built from something much more complex. Perhaps the lexical items contain structural information, more complex meanings, compositional meanings. Perhaps they specify in a more detailed way, more complex way, the grammatical environments where they could appear. So that's the obvious reason why this issue has to be faced with. And the third thing is that when we look at individual lexical items, we can easily notice that only some part of their, or some of their properties or meanings are relevant for language and especially syntactic processing. For example, if you take a proper name, John, this has linguistic properties like third person, it's singular, it refers to a male gender, so sentence like John admires herself is very odd or ungrammatical or exceptional because of that. It typically refers, it's always, let me be careful, it typically refers to an animate sentient object, a person even, rather than animal or a stone or a set or mathematical theorem. So we see that it has some properties that are relevant, but John, if it refers to a person who is your own child or a friend or spouse or relative or who is otherwise has had a lot of impact in your life, then it involves, at least in your case, many additional properties. So we have to make a distinction anyway between the lexical knowledge or lexical information more generally and then lexical information as it is relevant for syntax, for example. And one more thing I want to mention is inflectional morphosyntax. Case suffixes, case forms more generally, or agreement. So here, even if you could begin from the assumption that run and runner are two separate lexical items, when we are talking about case forms, this intuition does not anymore. This intuition is clearly wrong. So he, him, is clearly an alternative form of him that is used in specific syntactic object environments. So it implies that we have to have a theory where the syntactic structure and the word forms interact with each other. We want to describe these changes in the words of words, in the forms of words like case forms or agreement forms by relying on some type of computational productive mechanism. And we don't want to list all these forms in the lexicon as completely independent items or lexical entries. Just a note about the terminology. The term lexical entry usually refers to the refers to the data structure or representation that we have for some specific word or morpheme. That it's lexical entry. And lexical item usually means a lexical object or representation as it is merged or assembled or is part of some sentence that we are constructing. It could be also that the lexical entry has more information that appears in the lexical item, or that the lexical item is created from the lexical entry by applying some type of operations. Another reason why we want to make a distinction between the two. Okay, so those were at least four reasons why we have to do something with this oversimplified notion of lexicon. So let's first make some fundamental assumptions about the implementation. We have to create the lexicon in its own class and module. Separate class and module from the phrase structure class, for example. And one reason for this is the fact that the lexicon will eventually have to contain information that is not really relevant, or we want to create a system where we can add information to the lexicon or knowledge or lexical knowledge that doesn't affect language or grammar or syntax directly. This becomes important later on if we want to understand semantics. Then we have to probably very soon create, we will have to use this type of lexical encyclopedic information to restrict semantic interpretations or regulate how people comprehend sentences. And also the fact that the lexicon, in most theories, and there are empirical reasons to assume that the lexicon is something is based on its own complex system and complex entries. So all those things, it's best to define them in their own class where we can freely create a data structure for the lexicon exactly as we want to have it. So that's the first starting point. And then the second thing is that we need to create an interface where, given some lexical item, it is transformed, given a lexical entry, lexical knowledge or representation, we can transform that object into a lexical item. Usually this will be a primitive constituent that goes into the assembly processes. That would be a syntax-lexicon interface. It's a simple, it can be as its own module or even class as is in my current model, which handles the transformations and information flows between these two systems. Or it can be, if it's simple enough, it can be part of the speaker model, for example, which anyway controls the information flow within the whole architecture. Both are good starting points. And so we then take this lexical information. And another point, the lexicon class module will then contain all the functions that are specific to that domain. For example, loading the lexicons from the external files, creating language-specific lexicons, applying lexical redundancy rules if there are those, retrieving the lexical items. All the processes, lexical processes would be in that class. And then you get something into the syntax, usually primitive constituents, but Depending on how we want to treat phrasal idioms, it could be more general process. And then we will have something in the derivation, some type of primitive elements. And just to make a third brief comment about the architecture, if we work in the context of enumerative grammar, these primitive elements which come into the derivational search function, I call them myself, the lexical elements, that entries that provide them could be called root lexicon, meaning that it is a list of the absolute syntactic, non-productive, primitive stuff that we have to assume to create expressions, the root lexicon. It's everything that we don't create, or the language faculty cannot create by applying combinatorial mechanisms, assembly processes. And in some theories, the root lexicon could contain simply linguistic features, the so-called microsyntax, or I don't remember what the name was, but this is a possibility. So then the ultimate primitives that are combined are features, and then the composition of lexical items themselves, the primitive constituents, takes place inside the derivational search function, and soon I will describe how to implement it. But it's a crucial distinction. Then there are theories like I myself assume that the root lexicon contains feature bundles, feature sets, a little bit more complex than some simple sets, but that's not relevant here. Why? Because those sets are simply stipulated. They are not created by combinatorial creative process. They are acquired during language acquisition, or when we coin and create new words. So that makes these lexical items and entries part of the root lexicon. And then in theories that assume some type of complex lexical entries, if those entries are created stipulatively and they are not a product of free combinatorial processes, which I consider unlikely, but if they are, then they would be in the root lexicon. And anything and everything that can be created by some type of assembly process that is regulated by principles and is not completely ad hoc or stipulated or arbitrary, cannot be in the root lexicon and should not be stated in the lexical entries in the ultimate model we will have. Now, before I go into the main topic, I want to say about this that in a project or research work where the lexicon is not really the focus of the whole enterprise, if we are solely interested in some syntactic constraint or principle, in those circumstances, it's of course completely possible to ignore everything about the lexicon, and if we need complex words, we simply list them as lexical entries. And even if we assume ourselves that there are lexical processes that are productive and are part of the assembly system, we don't need to implement those combinatorial operations necessarily if that's not our focus. So that's what I'm claiming here. We can ignore these topics if they are not interesting or important for what we are doing. But if we go further from here and we think about how this kind of system then must be constructed, then it's obvious what we do next. And it is that every lexical operation, word formation operation, that we assume is based on general linguistic principles, laws, or rules. Those operations have to be performed by the derivational search function. So exactly the same way as when we combine words to create phrases like the and dog creates a noun phrase, the dog. If we think that running is produced by some type of productive creative assembly mechanism which combines morphemes, then that word formation rule, process, assembly operation has to be performed in the derivational search function, in the same function which creates phrases. And this is because we will have to, of course, justify also the theory of word formation against data. So we have to check that the word formation rules are valid or correct by allowing the derivational search function to try to generate all possible combinations and then applying the constraints or principles we have in the empirical part of the model and to check it against the data set. And so, and just to take another example, if we start with a theory where lexical items are complex structural objects, and we don't assume that they are completely arbitrary, but their construction follows some well-formedness rules, then instead of listing those complex lexical entries as in the root lexicon, as we could do if we are not interested in the lexicon in some of the study. But let's go beyond that. Instead of listing these complex lexical entries in the root lexicon, we should instead only list their primitive parts there and then have the derivational search function to create the complex lexical items by applying general structure building assembly operations, whatever they might be. I hope that I'm able to make this point clear. Why is this so? It's so because we can't simply imagine some type of lexical theory with complex lexical entries. It has to be tested as well. So we have to have the rules which produce those complex entries, and the mechanisms will have to be in the derivational search function so that we explore all possible ways and really check that the principles are working correctly. Now let me just point out a few different approaches that there are in the literature and how they would work in this context, work out in this context. So first of all, we have lexicalist theories. And lexicalist theories assume that the word formation operations, which create items like running, for example, that they take place or happen inside their own autonomous, independent lexical modular system. So we could, in theory, start from the assumption that the lexicon class has its own derivational search function, which then feeds into the syntactic derivational search function. The important point is that we expose the morphological theory to the derivational search also. But we don't really need to make that assumption, because remember, the derivational search function is part of the executive layer and it's not part of the empirical theory. So we would actually end up doubling something. And it's useless to have derivational search functions in our empirical modules, because they don't belong in those modules. They are not part of the empirical content. So what we do instead here is that we we add the word formation rules into the set of syntactic or list of syntactic operations that the one and only derivational search function is using when it's creating the derivational space. So there will be word formation rules and then syntactic rules and whatever rules, other type of rules we might want to test. And this can be organized in a way that our lexicalist theory is assuming by simply making it so that the root lexicon provides objects that are in the domain of word formation rules and not in the domain of syntactic phrasal rules. Just to give an example, this doesn't have to be so, but this is just a one way of creating a lexicalist model. So we make a clear distinction between the syntactic rules and the items to which they can apply. And then the syntactic phrasal rules only apply to the type of constituents which come out from the application of the word formation rules. They are in a layered sequence. But both rules are simply in the list of syntactic operations. Or actually, we should call them grammatical operations now if they belong clearly into two classes of operations, lexical and syntactic. So that's simply the way. And now the system will automatically create test word formation rules and syntactic rules together. And we can avoid applying the lexical rules if we want by having, for example, a parameter which puts them offline, or we can feed the numeration could contain simply finished complex words that we assume have been generated by the lower level word formation principles. So there is no technical problem in knocking the lexical component off. Now there is an opposite model to lexicalism in which the word formation is part of syntax. And so in this case, we simply have the root lexicon, the primitive elements, and then the same operations which create phrases from words with word boundaries. The same operations will create also complex words, running, runner, sleeping, and others. So that would be a syntactic theory. In both cases, we have the word formation in the lexical, in the derivational search function. So that's all I wanted to say in this presentation about how we can approach the lexicon. There's one leftover topic which I decided to address, and that's what to do with the morphosyntax, inflectional morphosyntax. And there are some approaches, different approaches that one could adopt. So I'm talking about things like case forms, case suffixes, and verb agreement. Let's take case as an example. So one way would be to, and let's assume we have enumerative grammar. One way is to take the root lexicon, and the elements of the root lexicon would be completely devoid of case features and case forms. So they would be caseless items. And then once the derivation is complete and it's sent to the post-syntactic function, or perhaps there would be an interface, then the case forms or features would be supplied by the post-syntactic function on the basis of the syntactic context of those elements. Or we could supply the case forms or features during the derivation. It's a little bit more risky when we are applying them, when we are using partial phrase structures for case determination, but surely it's possible. So in this model, the syntax or post-syntactic operations are creating the case forms and features. And then another way is that we can add case features or forms freely into the words, perhaps by stipulation. Perhaps there would be an operation that would apply case forms completely freely as part of the derivational search. And then those features would be checked against their syntactic context during the derivation or inside the post-syntactic function. So case assignment or creation of case form one way, case checking plus free generation of case forms is another solution. In a recognition grammar, we really should start from the case checking approach. So the case forms would then be read off from the input words and then checked against their syntactic contexts at some point during the derivation or assembling the underlying syntactic structure. So those are three approaches that one could do this. Assignment, so syntactic context is changing the shapes or feature content of some constituents. Option 1. Option 2, we could have a separate productive assembly operation which is able to add certain features to lexical elements, primitive items, at the beginning of the derivation or during the derivation, and then there would be a checking mechanism. And finally, in a recognition grammar, we would have the case forms available in the input, so there is no free generation of any features. And then they would be checked against syntactic context. And we have, of course, case concord still left, where we have a case form distributed over several nominal elements. Finnish is a language which exhibits this type of case concord. So the same distinctions apply here. We could assign those forms independently and then have a mechanism which causes all the nominal words to have same case forms, or we could read them from the input in a recognition grammar and check each of them, or we could create them freely and have some kind of concord checking procedure. But those are the, in my view, plausible starting points. Perhaps there are others. But what we should rule out is a system where all case forms are always listed in the lexicon as separate entries. So I think that was it. That was all I wanted to say in this presentation. Just a brief summary. We can start off by using an extremely simple lexicon where it's just a collection of words, perhaps each lexical entry containing a set of features. That's a useful starting point in the beginning, but sooner or later we discover that this is insufficient. We can assemble complex words from primitive parts like morphemes, like we can create complex phrases, so that process has to be described somewhere. And many theories and on plausible grounds assume that lexical items are more complex things than simply a list of lexical feature sets, for example. And the approach I think is the best here is to create a separate class or module for the lexical processes and lexical representations and have all the lexical processes and computations performed in that separate module or class. And then we pick up or retrieve elements from there transform them into primitive constituents, lexical items that will be exposed to the assembly operations. And complex words would be created by using either the regular syntactic assembly or perhaps its own specialized word formation rules, both of which are treated as grammatical operations that the derivational search function can access. And this is then we have a system where we can not only assume lexical theories or hypotheses, but we can also test them against concrete data.